Once again, a very good evening to you all, and welcome to today's class. This is a continuation of our CCNA1 networking training for instructors, and we'll be looking at module 11 and 12 today. A very important aspect of networking is IP addressing. And it is a very technical aspect because there's a lot of calculations therein. So we'll be looking at IP version 4 and then IP version 6. And then hopefully maybe tomorrow we'll look at the concept of subnetting. Okay. I don't want to combine both the IP addressing and the subnetting together. It may be a little bit too much. So we're looking at module 11, IP version 4 addressing. For today. And under it, we would look at the concept of unicast, broadcast, and multicast. We'll also be looking at the types of IP version 4 addresses. Then we will look at the concept of network segmentation. Okay. Now let's go into it. What is a unicast? You know, when we started talking about communication over the network, we mentioned a few things about the unicast, the multicast, and the broadcast. So in IP version 4 addressing, it has what we call a network portion and a host portion, especially when you use the word uni, you are talking about one. So you have one device communicating to another one device. So an IP version 4 address has a network portion and a host portion. There are different ways to send packets from a source device, and these different transmissions affect the destination IP version 4 addresses. Okay, so what we are saying is generally an IP address has two sides. All right, it has the network portion and then the host portion. All right, so when we say unicast transmission, we are talking about one device sending message to one other device. So it's like a one-to-one device. Maybe you have a PC here sending a direct message to another PC. That's like unicast. So unicast packet has a destination IP address that is a unicast address, which goes to a single recipient. And a source IP address can be a unicast address because the packet can only originate from a single source. So this regardless of whether the destination address is a unicast, broadcast, or multicast. Now, you may want to find out what then is the IP address that we're talking about. An IP address is like a unique identity that every network device must have in order to communicate over the network. So it's like saying a student is admitted into a school, that student needs a matric number, and that matric number uniquely identifies that particular student. So anywhere you go, maybe you work, you have your staff number, or you have your driver's license number, or you have your BVN number. All those numbers or NIN number, they are unique. So a device that must communicate over the network must have that number, right? And that's where we talk about IP address. Okay, so IP version 4 unicast host addresses are in the address range of 11111 to this particular number. It may look strange at first, but very, very soon you will see that it's not really strange. That's strange actually. So within this range, there are special purpose address reserved, you know, and for this particular module, we will discuss some of these special addresses much later. So in the animation, notice that the slash notation of /24 represents the subnet mask of 255.255.255.0. This indicates that the subnet mask is 24 bits long and the subnet mask is represented in binary. Like I said, that a unicast is when you have a message probably from a sender to a receiver. So it comes from one device and comes to the other device like this. Very simple. That's a unicast. And we said that an IP address is a unique number that every device must have. So you see, like this computer here, it has an IP address. This one has an IP. This is having an IP, and this is having an IP. Okay, now these IP numbers that we are seeing are supposed to be represented in binary. And in binary, we are saying that they represent, how do I put it? A 32-bit binary digit. So when we say 32-bit binary digit, so an IP address like this is in decimal. If you convert it to binary, it is represented this way. Now, there are some few things that you need to know about IP version 4. Number one, we said it is 32 bits. All right? It's 32 bits. Then number two, this 32-bit is divided into 4 octets. When we say octet, what do we mean? We mean that there are 8 bits inside one octet. Okay? So inside 4 octets. So this is 1 octet. This is 2 octet. This is octet 3. This is octet 4. I'm sure you can see it now. So you see, these are the 4 octets. All right? So with these 4 octets that we have here, if you are to count the number of bits inside each of the octet, inside here, if you count how many ones are here, you will see that you have 8 ones. You see here, there are 8 ones. You see here, there are 8 ones. There are 8 ones. So an IP version 4 has 32 bits, and these bits are in binary. Number 2, it has 4 octets. All right? And then you have 8 bits in each octet. So this is octet 1, octet 2, octet 3, octet 4. And in each of these have 8 bits, right? Now, the other aspect is the broadcast. We have looked at unicast. Unicast means one-to-one, all right? You can see here, one PC communicating to one. But in the case of a broadcast, it's a transmission that requires sending from one device, all right, and then to all. Maybe there's a switch here, and then there are some other devices connected. So this message comes from here, and then it goes to everybody. It's like your television at home. When you go to the radio, the TV station, the TV stations do what we call transmission. Okay, so they will transmit the message, and everybody that has TV in his house is going to be receiving the message. Once you have TV in your house, you're receiving it. That is one to all. Okay, that's the key element there. When you say one to all, that is one person is sending message and everybody on the network is receiving it. That is a broadcast. So a broadcast packet has a destination IP address with all of the subnets as 1. All of the bits as 1 in the host portion of 32 bits. So remember we said an IP address has, let's go back, has 32 bits, has 4 octets, all right? It has 4 octets, it has 8 bits, and then it also has 2 portions, all right? It has 2 portions. It has what we call the network portion, and it has the host portion. Now, the network portion identifies like the surname. The host portion identifies the name of the person. Okay, so for instance, now, if a man has 5 children in his house, and his children all carry his surname, okay, now when they are going out to school, all the children will be carrying the same surname, which is the network portion. But once they come back home, you don't expect their father to be calling them by their surname. No, they will be called using their host name. So that's why we are saying that the broadcast packet has a destination IP address with all ones in the host portion, or 32-bit 1. All right. So you should note that IPv4 uses broadcast packets. However, there are no broadcast packets in IPv6. So IPv6 has what we call Unicast. We're going to see that. So all devices must possess a broadcast packet in the same domain. All right. So a broadcast domain identifies all the hosts in the same network segment, and a specific network sends a direct broadcast to all hosts. Okay. So a domain is like a family name. Okay. Family name, all the people in that particular family will get that particular information. Right. So now that is it. A broadcast packets use resources on the network and makes every receiving host on the network process that particular packet. Therefore, broadcast traffic should be limited so that it does not adversely affect the network performance or devices. So because routers separate broadcast domains, dividing network segments can improve performance by eliminating excessive broadcast traffic. So if you have maybe in your house or in your office, you have maybe an access point, okay? And that access point is connecting to multiple users, people with their phones, their laptops, their desktop, and, wirelessly, okay? Now, what we are saying is that this AP is a broadcast device. If it receives any signal, it's going to broadcast it. We are saying here that sometimes if you have multiple of these APs or you have a switch is a broadcast device also. You have a switch or an AP. They continue to generate broadcasts because that is how they are created. Once they receive a message, they begin to shout it to all the nodes on the network so that they will be able to know and see. So that's what happened. So if that happens continuously, it generates a lot of traffic on the network, and then it gives you traffic congestion. Okay, there will be congestion, so your network will be slow and things like that. However, there are ways you are going to mitigate that, and one of the ways is by using a router. A router will then actually segment that network and break that particular broadcast. The third one is the multicast. So we have seen a unicast, which is message from one to one. We have seen a broadcast, which is message from one to all. Now, a multicast here is a message from one to some. Okay, it's like in the same family group. The father has message, instead of, if it is one to one, he will call maybe his first son and give him the message. If it is one to all, is to send message to all his children in the family. If it is multicast, one to some, which means maybe he'll call all the ladies in the family and give them the message or something like that. So a multicast transmission actually reduces traffic by allowing a host to send a single packet to a selected number of hosts that subscribe to that particular multicast group within that network. So a multicast packet is a packet with the destination IP address that a multicast address. Okay, when we come to look at the IP addresses, the classes, which we are going to see very, very soon, you will see that we have different classes of IP addresses, class A, B, C, D, E. Okay, now one of the classes is a multicast address. It's an address that is used for multicast messages. All right, and that particular address falls within this particular range of address. 224.0.0.0 up to 239.255.255.255. So hosts that receive multicast packets are called multicast clients. So the multicast clients use services requested by a client program to subscribe to the multicast group. So a single IPv4 multicast destination address represents each multicast group. So when an IPv4 host subscribes to a multicast group, the host possesses packets addressed to this multicast address, and the packets to uniquely allocate unicast address as well. Now, routing protocols such as OSPF or use multicast transmissions. Now, when I say OSPF, is a particular type of routing protocol that dynamically populates your routing table. So OSPF stands for Open Shortest Path First. Okay, when we come to talk about the routing, you will now hear a lot about OSPF. Okay. Now, what are the different types of IPv4 addresses? We have what we call the public IP address. We have what we call the private IP address. Okay. What is the main difference between the two? The public IP address is routable over the internet, while the private IP addresses are not routable over the internet. So just as there are different ways to transmit IPv4 packet, there are also different ways of IPv4 addresses. So some IPv4 addresses cannot be used to go out to the internet, while others are allocated specifically for routing to the internet. And some use a very used to verify a connection, while others are self-assigned. Okay, so your internet service provider or your ISP, they use those public IP addresses globally because most of the traffic that goes around the internet, it uses public IP address. However, not all available IPv4 addresses can be used on the internet. So there are blocks of addresses that we call private IP addresses that most organizations use to assign IPv4 addresses to internal hosts. So if I have, remember we said that every device is uniquely identified by an IP address. So if I have a device that needs to connect to the internet, then nobody else should be using that particular IP address at that moment in time. So if that's the case, the available IP addresses will not be enough for all the devices globally to be able to connect with their own unique IP addresses. So the need for separation between the public and the private, which means if I have a private IP address, I can use it and another person can still use it, another person can use it. What do I mean? If, for instance, I have 4 children, and one of them, maybe her name is Zainab, then the other one, her name is Amaka. Okay, then the third one, maybe her name is Kemi. So I have Zainab, Amaka, and Kemi as my children in the house. Now, I can go to another family and have the same name, Zainab, Amaka, and Kemi, in that house. Then you can go to another family. You will have another man having his children to bear. Maybe if he has just one, maybe he gives her a name, Zainab. Okay, so I can walk to a classroom and ask, who is Zainab? And possibly 4 people will stand up and say, my name is Zainab. Okay, so that means that is a private IP addresses. Those IP addresses are known locally. They are just known locally. So if I have these 4 children, their name is Zainab, Amaka, and Kemi, when they are going out, they are not known as Zainab, Amaka, and Kemi. They need to carry their name. So maybe Zainab Dapel, or Amaka Dapel, or Kemi Dapel. So you see, they have the surname Dapel. Now, that surname is the, how do I put it now? Is the public IP, because that is the name that is routable over the internet. That's the name that others will use to differentiate who these girls are. So internet service providers actually use these public IP addresses for that. Okay, and that really helped a lot. Now, how do you know the difference between these private IP addresses and public IP addresses? Remember that we said that an IP address has 4 octets, okay? And in each octet, there are 8 bits in binary. Now, in binary, you have either 0 or 1 that is in binary. And so if I have 8 bits inside 1 octet, the lowest value I'm going to have is 8 zeros. All right, maybe 1, 2, 3, 4, 5, 6, 7, 8. That is 8 zeros in one octet. That is the minimum that I can have in binary. Okay, and if you convert it to decimal, you will have 0. Now, the maximum I can have in another octet is 1, all ones, because it's binary. I have 1, 2, 3, 4, 5, 6, 7, 8. All right, that is another octet. If I convert this one to decimal, I'm going to have 255. Okay, so which means the lowest value I'm going to have in IP addresses is 0. And the highest value I'm going to have in IP addresses in an octet is 255. Okay, now within the concept of IP address, remember we said it has what we call the network portion and it has what we call the host portion. Now, the network portion is like the surname, the host portion is like your first name or your local name. All right, the network portion is like the family name, because let's say all my children will be bearing Dapel. All right, all of them will be bearing Dapel is the family name. So if you have a LAN with 200 computers there, all of them will have the same subnet mask. What is a subnet mask? A subnet mask identifies the network portion of an IP address. So it helps you to know what is the surname or the family name of that particular IP address. So all the systems will be having that. Now, how do you know the subnet mask? That is where they use this slash notation. You'll see this slash notation. All right, we're going to explain that very, very soon. So now we need to know the private and the public IP address. Now, having known that the lowest value is 0, the maximum value is 255, here we have what we call class A private IP address. It starts from 10.0.0.0 up to, look at it here, 10.0.0.0 up to 10.255.255.255. That is, any IP address within this range is a private IP address for class A. We're going to talk about the classes very soon, okay? For class B, the private IP address is 172.16.0.0 up to 172.31.255.255. For class B, this is the private IP address. For class C, this is the private IP address, 192.168.0.0 to 192.168.255.255. This is a class C IP address, a private IP address. What this means is that I can use the same IP address in my branch network in Jos, another branch network in Lagos, another branch network in Kaduna, another one in Maiduguri, another one in Port Harcourt, and so on and so forth, and nothing will happen. But if it was a public IP address, I cannot have all of them at the same time. Okay? I cannot have all of them at the same time. So the concept of private IP addresses is just to help conserve the number of IP addresses. Since they cannot be routed over the internet, you can only just use them locally. So if they need to go out to the internet, they will need them to be translated. Okay? Now, most internet networks, from large enterprises to home networks, use private IP addresses, like I explained to you. So even now, if I check my computer, let me show you the IP address that I have on my computer. Then you will know that you know what I mean. Let me see. Let me share. Right. All right. So you see, if I say IP config, okay, you see, if I say IP config, what do you see? You see, this is a 192.168.0.140 IP address. With this, it tells you that I'm using a local IP address or a private IP address. All right. And the subnet mask 255.255.255.0. All right. It's a class C IP address. And this is the IP address. But if I am going to the internet, what IP address am I going to be using? Very big question. All right. What IP address will I be seen as since I'm supposed to be using what do you call it now? Since I'm supposed to be using a public IP address to go to the internet, what public address will I be using? So let me share my screen so that we'll find out. All right, this private IP address that I'm having, if I am going to the internet, what public IP address will I be seen with? Okay, so I can just say, what's my IP? Okay, so let's see what IP address that I'm having. Can you see your IP? My IP is what? 102.91.103.89. It says that's my public IP address. Okay, sure you can see it now. Just zoom it. Okay, so this is my public IP address, but my private IP address is showing something different. This is what my private IP address is showing. And you see, my private IP is this and this are not the same thing. So if you check within the IP range, you will see that this one falls within the range, but this one is not within that particular range. Okay, so that's the concept. Before ISPs can forward packet, it must translate. It must translate the source IP address, which is a private IP address, to a public IPv4 address using what we call network address translation. Okay, so NAT is used to translate between IPv4 address public and private. So like what I've shown you, I have a local IP address, but when I'm going out to the internet, the IP address is translated to a public IP address. And if that is the case, somebody must be doing that particular translation. Okay, and so it will translate between my public and my private. Okay, so I see somebody is raising hand. I don't know. Can you wait after the class? Then you ask the question. I'm talking to Rabo. All right, thank you very much. So let's continue. Just take note of your question. Once we are done, then you can ask your question. Now, we have special use IP addresses for IPv4. Okay, and when we say special use, they are like IP addresses that are not that are automatically given. So we call them linked local addresses. All right, they are more commonly given automatically by the operating system that you are using. They are self-assigned. So a Windows client uses them to self-configure if the client cannot obtain an IP address through maybe DHCP or maybe statically or something like that. So a linked local address can be used in a peer-to-peer connection, but are not commonly used for this purpose. So this is the address for the linked local 169.254.0.0/16. So if you are setting up your network, or you have set up your network and you are not browsing or you are not reaching out somewhere, and you go to check my IP address, and the moment you see 169.254, just know that it is assigned to you by your operating system. All right, so it falls within this particular range. Then another special IP address is called the loopback address. Okay, is 127.0.0.1, and it's a special address that is given to a host, like the network interface card. Okay, so whether you are connected to the network or you're not connected to the network, if you just ping 127.0.0.1, you will get a reply. And that reply is to tell you that your network interface card is functioning, right? So that is it. Then you have what we call the legacy classful route addressing. Now, in 1981, IPv4 addresses were assigned using classful addressing defined by the RFC 790. All right. Customers were allocated a network address based on the three classes, A, B, or C, and divided the unicast range into specific classes. So you see like class A, all right? Now, for you not to get confused, remember I said we have private IP addresses and public. And what I showed you earlier on was private IP addresses. Now, the class A block, this one contains everything from public to private. So how do you get to know the class of the IP address? Forget about all this number. Just look at the first octet. So let's be looking at the values in the first octet. For class A, it ranges from 0 to what? 127. That's all. All right? From 0 to 127. That is what you get in class A. All right? So if I have an IP address 1 or 2 or 3 or 4 or 5 in the first octet, you will know. So if I'm to check, where is it? If I'm to check this my public IP, this my public IP. If I'm to check the first octet here, this is 102. So since it's a public IP address, what class of IP will it be? So you see, since it's 102, it falls within this range. All right, so it's a class A public IP address. So this class A is designated to support vast network with more than 16 million host addresses. A class A used a fix /8 prefix. Now, when you see this slash notation, the slash notations are to tell us the subnet mask. Remember, we said a subnet mask identifies the network portion of an IP address. It only tells us how many bits are 1. Remember when we talked about this 0 means in the first octet means everything there is 0. This 127, if you convert it to binary, you will know the binary value. Okay, so the slash notation tells us how many bits are 1 in the subnet mask. Okay, then class B, interestingly, we're not going to focus on only the first octet. Class B says that you have from 128 to 191. Okay, 128 to 191. I think I have to mute you guys. 128 to 191. What do you see? You see that we have 0 here to 127. The next value after 127 is what? 128. So it's a continuation. All right? 128 to 191. Then you see class C continuous. 192. Because this ends with 191. The next one after 191 is 192 to 223. 192 to 223. So that is how you get to know which one is class A. Now, the next one is class D. We're going to see that very soon. It continues from this 223. After 223 is what? 224. 224 to 235. All right. Then we will now see another class that starts from 236. You understand? So the class notation starts from the value 0, and then it goes like that. Class A 0 to 127, class B 128 to 191, class C 192 to 223, and so on. And these are values in the first octet. All right. So you see that class A carries half of it, the 50% of the entire block. And that is why it is assigned to large corporations, large corporations. Okay. So class B is attached for medium. So it takes 1/4. It takes 25%. Then class C, all right, is for small distance. Then class D and E are sharing this. So that is how it is. So class A 0 to 127, B 128 to 191, C 192 to 223, D 224 to 239. Okay, so you see, I even made a mistake earlier on. 224 to 239. Then E is 240 to 255. Okay, 240 to 255. So those are the addressing ranges. Okay. So how are these IP addresses assigned? So the internet globally routes public IP addresses, and these addresses must be unique. And for that to be unique, the internet assigned number authority managers, or we call them IANA, all right, are the ones that are responsible for this allocation, because it has to be unique. So they are responsible for this allocation. So the IANA manages and allocates the block of IP address to the regional internet registries. The regional registries now allocate the IP addresses to the internet service providers. That's like the ISPs, like MTN, Glo, Airtel. They are all ISPs, right? So that they can now provide to other smaller organizations, right? And get to their own. So every organization will have its own. So for instance, if I am checking my own IP address, this one that I see here. So if I want to know who is my ISP, who registered this particular IP address, I can just come here and ask the question. Who is, I do like this. So it's supposed to give me the ISP. Can you see? It's giving me the person that is registered this ISP is this person, MTN Nigeria. And you see, this is MTN Nigeria. All right. So this is so many of their block of IPs. That is also, it's the IP address is owned by MTN Nigeria Limited, blah, 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 blah. So that is it. And who gave MTN Nigeria is Afrinic. Afrinic is a subset, a part of IANA. All right, that handles Africa. Here, look at it here. So IANA has different registrars that registers it. So there are basically 5 registrars. We have Afrinic, and Afrinic is centered on but basically African countries. Okay, then you have the APNIC. Okay, then you have the RIPE. Okay, then you have the ARIN. Then you have the LACNIC, right? So these are the 5 global internet regional registrars. So the entire IP, public IP, is managed by these 5 registrars. And these 5 registrars are managed by IANA. Okay. So the AFRINIC, African Network Information Center, is for the African region. The APNIC, Asia Pacific Network Information Center, is for Asia Pacific region. The ARIN, for American Registry for Internet Numbers, is for North American region. The LACNIC, Regional Latin American and Caribbean IP Address Registry, is for Latin America and Caribbeans. Then the RIPE NCC is for Europe, Middle East, and Central Asia. Now, let's look at network segmentation. When we say network segmentation, what do we actually mean? We actually mean that the network is broken down into different sections or different partitions or different segments so that you can reduce the broadcast. Remember, we talked about the broadcast domain and broadcast, how it affects the network. So once you break this broadcast, it means that you have smaller groups of independent networks. Okay, so an Ethernet LAN device use a broadcast and the address resolution protocol to locate other devices. Okay, that is what it uses. All right, so the ARP sends layer 2 broadcast to a known IPv4 address on the network. Okay, so devices on the Ethernet LAN also finds other devices using services. Okay, so a host typically acquires its IPv4 address configuration using DHCP configuration, particularly to help give them identity on the network. So switches propagate out all interfaces except the interface by which it comes from. So it's a feature that a switch has. So when you are talking about a broadcast domain, we are saying that since a switch is a broadcast device, once it receives a message in one port, it sends out the message through all the ports. If a message enters through one port, it goes out through all the ports. That's how a switch functions. But a router does not function like that. So a router, even if a router has, you see, it has 1, has 2, maybe even if it has 3 and 4 interfaces. If message enters one port, it does not go out through all the other ports. It only goes out through the port that is expected to go out through. So a router breaks domain. So like this, you see this particular interface where it's coming like this is broadcast domain. Why? Because this switch, anytime it receives message, it will send here, it will send here, it will send here. This switch, once it receives, it will send through all the ports. This one, once it receives, it will send through all the ports. You see, it will send through all the ports. So within your LAN, if you have so many broadcast domains, okay, so many collision domains, if you have different broadcasts that is coming in, once the traffic comes to the router here, the router breaks it. It does not go out through others except being directed or configured to. So routers do not propagate broadcast. So when a router receives a broadcast, it does not forward it to other interfaces. All right. So for instance, when router 1 receives a broadcast on the gigabit Ethernet interface, it does not forward it out through another interface. Therefore, each router interface connects to a broadcast domain and only propagates within that specific domain. Okay. So a large broadcast domain is a network that connects many hosts, and that's a problem. Where there are so many hosts on that network, it generates humongous broadcast. So a problem with a large broadcast domain is that these hosts can generate excessive broadcast and negativity will affect the network. So you see the network becoming slow and congested. All right. So, for instance, if you see this picture here, LAN 1 connects 400 users, which could generate excessive broadcasts, right? So this results in slow network operations. Due to the significant amount of traffic, it can cause and slow device operations because a device must accept and process each of the broadcast network. So the solution to this particular problem, instead of having everything 400 users in one network, is the way to go about it is to segment it, separate it. Instead of 400, you will have 200. So this is like a solution, and this solution is called subnetting, right? So you'll see you'll have previously here, you have 400 users, and see the IP address 172.160.0.0/16. And so if you subnet it, which we're going to be doing by next class, /16, if you subnet it, you will see that this one becomes /24/24. So it's broken down to 2/24. How did they get this one? Don't worry. When we come to talk about subnetting, we're going to face that squarely. So notice how the prefix length have changed from a single /16 network to 2/24 networks. This is the basis of subnetting, using host bits to create additional subnets. So the use of the term subnet and network are interchangeable. Most networks are a subnet of a higher address block. So a higher address block is usually known as a supernet. Okay. Now, why then do we do subnetting? Right? We do subnetting to reduce the overall network traffic and improve network performance. Okay. And then it also enables an administrator to implement security policies, such as which subnet you are to allow or which one not to allow, maybe bandwidth allocation, or maybe security policies and things like that. Another reason is that it reduces the number of devices that is affected by an abnormal broadcast traffic, maybe due to misconfiguration and things like that. If, for instance, there's a virus attack on the network, it will only affect that segment that that it's been affected. Apart from that, you would be free. Or if there is maybe an IP conflict, it will affect the network, but it will affect only that segment. So it's good to segment your network. So there are also various ways of using subnets to help network devices. So if I have maybe a particular company, or in my organizations, I have different floors, maybe floor 1, 2, 3, 4, 5. All right. Now, with these particular floors, I can decide to segment to have them with different subnets. So if you look at this IP block from LAN 1, you see 10.0.1.0. LAN 2 says what? 10.0.2.0. The other one, 10.0.3.0. The next one, 10.0.4.0. 10.0.5.0. The IPs actually tells us that these are all on different segments. But there is a router here. What is the job of the router? The router here is to say that if somebody in LAN 1 here wants to talk to somebody in LAN 2, he has to come to the router, and it's the router that will route him to that LAN 2. And the same goes to 3, 4, and 5. All right. And if they want to go to the internet, they have their own path to the internet. And when you're subnetting in terms of group, for instance, instead of doing it based on locations by floors, you can do it in terms of group. Maybe you say administration or human admin block, or you can have this, or human resource. can have a particular segment. You will have another segment for students, another for accounting, another for staff, and so on and so forth. So you can have different segments of the network segmented, based on their functions. So you see, we can do it based on, subnet it based on location, or we can subnet it based on their function, whichever one that we want to do. We can also do the subnetting based on device type. All right, device type. We can have a subnet for printers. We can have a subnet for servers. We can have a subnet for hosts, things like that. So these are some of the reasons that we can do to have our subnets. So network administrators can create subnets using any other division that makes sense for that particular network. And the most important thing is that the network administrator knows what he or she is doing. So understanding how to subnet network is a fundamental skill that all network administrator must develop. Underline the word must. So you must be able to know how to subnet if you want to become a network administrator. All right, so there are various ways or method of doing subnetting, but when we come to do our own, we will take a look at it. Okay, so that is the overview for IP version 4. Let's look at module 12 to look at IP version 6. It's brief. Okay, we're going to look at the issues in IP version 4 that led to the creation of IP version 6. And then we're going to look at the IP version 6 addressing. So the issues here in IP version 4 was that they noticed that IP version 4 is running out of address space. And that was why you need to learn about IP version 6. When we say IP version 4 is running out of address space, we are saying that it is finishing. We have observed that this is not enough. There are too many devices that that require public IPs, and the public IPs are not sufficient. And that's why you're going for IP version 6. So another reason for us to understand IP version 6 is IP version 6 is designed to be a successor to IP version 4. So very, very soon, you will see that most devices will be using IP version 6, probably because of the IoT devices and stuff like that. What's another reason for IP version 6? It has a larger space. Remember, in IP version 4, we said it's a 32-bit binary. But you see, in IP version 6, it is a 128-bit address space and is providing a total of 340 undecillion public possible addresses. When you say undecillion, it's another thing entirely on its own. So IP version 4 provides its own in billions, but this one is on undecillion. It's like how many times, like 5 times or 6 times or 10 times bigger. Okay, so when the IETF means Internet Engineering Task Force, began its development of a successor to IP version 4, it used this opportunity to fix the limitation of IP version 4 and include enhancement. One example is the ICMP version 6, which includes address resolutions and address auto configuration not found in ICMP version 4. So the depletion of IP version 4 address space has been the motivating factor for moving to IP version 6. So as Africa, Asia, and other areas of the world become more connected to the internet, there are not enough IP version 4 addresses to accommodate this growth. So IP version 4 has a theoretical maximum of 4.3 billion addresses. So compare that with about 340 undecillion. So the private IP addresses in combination with NAT have been instrumental in slowing the depletion of the IPv4 space. However, NAT is problematic for many applications. It creates latency, which means it's a little bit slower, and has limitation that severely impede peer-to-peer communication, which means that because there is a translation in NAT, you have traffic coming in and it has to be translated, you may not be able to do end-to-end connectivity. So with ever increasing number of mobile devices, mobile service providers have to find a way to convert to IPv6. So the top two mobile providers in US, the one that we know, most of them, YouTube, Facebook, Netflix, they have made their transition. They have moved from IPv4 to IPv6 to make things faster, more efficient. Many companies like Microsoft, Facebook, and LinkedIn are transiting to IPv6 internally, all right? So Internet of Things is another reason. And the Internet of Things today means that everything you have will be connected to the internet. And if that is the case, the IPv4 will not be enough. So the need for IPv6. Abubakar, I've seen your hand. We're almost rounding up so that you can ask your question. So the evolving internet is becoming an internet of things. And the devices accessing the internet are no longer only computers, tablets, and smartphones. We have fridges, we have cars, we have smartwatches, we have glasses, spectacles, you have almost everything, okay? Almost everything. Household appliances, ecosystems, and things like that. So because of that, there's need for IPv6. But are we going to just do away with IPv4? The answer is no. They're going to coexist. So there's a technology that is available so that the two IP addresses will coexist. So until the one faces out. So one technology is called the dual stack. Okay. This dual stack allows IPv4 and IPv6 to coexist on the same network, which means some computers will get IPv4, some computers will get IPv6 on the same network. Some will even get both. All right. So its devices run both IPv4 and version 6 simultaneously, and the customer network has an version 6 connection to their ISPs and can access content found on the IP and the internet over IPv6. So if they have both version 4 and version 6, they will use version 4 to talk to each other locally, and then they will use version 6 to go out. So we call it dual stack. Another technology that they need in order to coexist is called tunneling. Okay, so you see in the dual stack, everybody both IP addresses will run concurrently, and every host on the network will get it. But in the aspect of the tunneling, from the word tunnel, it's a method of actually transporting the IPv6 packet over an IPv4 network. Okay, now that happens especially in the area of the ISP, where the ISP is actually working. So you could say maybe you have internally, you have maybe IPv6, but your ISP is running IPv4. So what do? You do tunneling. So your IPv6 is like it's like a kind of NAT. It's like a kind of NAT. The IPv6 will be encapsulated into the IPv4, and then it will tunnel once it gets to the destination, and then it will now come out and continue. So that is tunneling. Then you have another technology called the translation. It's like NAT. Remember we talked about NAT? So this is also another type of NAT. How does it happen? Maybe in one network, you have IP version 6 only. In another network, you have maybe IP version 4 only that is existing there. So on the router, you can configure it to do what you call NAT 64. That is NAT for IP version 6. Now, what will happen is that when traffic here is crossing here, it will be NATed. When this one is crossing here, it will be NATed as well. Okay, so for coexistence, we said you have dual stack, you have tunneling, and then you have translation. So how is IP version 6 addressed? Remember, in IP version 4, we said it is addressed in 32-bit binary or is addressed in 4 octet of 8 bits each. Okay, and that is what we said. And we also said that it has network portion and host portion. Now, in the IP version 6, it also has the network portion and it has the host portion. That one is there. And then instead of 32-bit binary, it has 128-bit binary. Instead of 4 octets, it has 8 segments. All right, it has 8 segments. Now, in IP version 4, each octet has 8 bits in binary. But in IP version 6, each segment has 16 bits. 16 bits. And the 16 bits is represented in hexadecimal. Represented in hexadecimal. Now, in IP version 4, remember we said the lowest value is 0000. The highest value is 1111, which is 0 to 255. That is what it is. But you see, in IP version 6, because we are representing it in hexadecimal, the lowest value is 00000. The highest value is FFFFF. So if you convert it to decimal, you will now get the value. If you convert 000 to decimal, you also get the value. So what we are saying is that it has 16 segments, 8 segments. This is 1, 2, 3, 4, 5, 6, 7, 8. And in each segment, there are 16 bits binary. They are 16 bits binary and represented in hexadecimal. Okay. Now, the previous figure shows that the preferred format for writing IP version 6 is this way. See it? Where this X consists of hexadecimal values. All right. You see the hexadecimal values here. So the term octet refers to 8 bits of IP version 4 address. In IP version 6 is a hex test and is the unofficial term used to refer to segment of 16 bits or 4 hexadecimal values. Now, each X is a single hexet, which is a 16-bit or 4 hexadecimal digits. All right, preferred format means that you write a 16 IP version 6 address using all your 32-bit hexadecimal digit. It does not necessarily mean that it is ideal method for representing IP version 6 addresses. But what we can see, this is like the value, all right? I can see this is this. Now, there are ways that you can make it look even easier, all right? Now, in this particular way, it tells us about 3 rules that will help us represent or understand how IP version 6 works. The first rule is that omit the leading zero. If you have an IP version 6, this is an IP version 6 address, you see it. You see the first segment or the first exit says 2001, okay? There's no leading zero. Leading zero is where zeros are leading. The second segment says what? There is zero in front. The third segment, in fact, there are multiple zeros all through. The fourth segment, there is no zero. Fifth segment, the fifth segment, 0, 0. The sixth segment, 0, 0, and things like that. Then here, there is just 2 zeros. So in rule 1 is saying that omit the leading zero. So for instance, if you look at this one here, I have 0, 1, AB. I will represent it as 1AB. I have removed or omitted the leading zero. This one is 0, 9, F0. There's a 0 at the end, but I'm not touching it. So I'll just represent it as 9F0. If I have this one 0A00, I'll just represent it as A00. All right, this one is 00AB. I'll represent it as AB. So the rule is only for the leading zero, the zero that is in front. Okay, so that is that particular rule. So if you look at it here, no leading zeros. You see DB8, then 0, then 111, then 000, then 200. That is rule number 1. So once you see an IP address and it is less than 4 hexadecimal bit, then you know that the leading zeros have been removed. The same thing goes to this one. If you look at this one, the leading zeros have been removed here. All right. If you look at the next one, leading zeros have been removed and things like that. So that is it. Let's look at the rule number 2. The rule number 2 says double column. The second rule to help reduce the notation of IP version 6 address is the double column. All right, this is the double column. When do we need it? And how does it help us in reducing the length of IP version 6? Okay, so for instance, you see this IP address, we have removed the leading zeros. So you are left with 2001, column DB8, column CAFE, column 1, column 0, column 0, column 0, column 1. All right, leading zeros omitted should be represented as this. How did you get it? You see, this is a continuous zeros. Continuous 0 here. You have 0, 0, 0. You have like more than 1 0 together. So you can just replace it with the double column, and that's all. That's what this rule is saying. If you have more than 1 0, leading 0, you can just replace it with double column. So, and it can only be used once within an address. Otherwise, you will have a problem. Okay, so we are saying rule number 1 is remove leading zeros. Rule number 2 is double column. Where you have continuous zeros, you can replace them with a double column, right? So look at this, for instance. If you look at this one here, you see there is a continuous 0 from here to here. All you just need to do is replace with a double column. All right. Once you replace with a double column, then you have gotten it right. Now look at this one here. There's a 0 to here. This to here. Can you see double zeros? Then look at this one here. So, and the rule says we can only use it once. So you look at the one that has the longest. This one has the longest. So we represent it. You see the double column here. And then here, we'll just put 0, 0. If you look at this scenario here, you see here, this is where we'll replace with the double column. All right. In this scenario, you see here, we replace with the double column, and so on and so forth. Now, look at this, for instance. If I have this all through like this, I can just put it as double column 1. That is just it. Or you can compress it as just double column, and then you are good. All right. How about if everything is 0? If everything is 0, you just put your double column, and then you will be good. Right? So this is where we will draw the curtain for today's class. We will take questions. If you have a question, you raise your hand while I will enable our attendance so that we can sign in our attendance. All right, so I have my first questionnaire, Anna Oluwaseun Victor. Please unmute and ask your question. Is it Aina or Anna? Aina Oluwaseun Victor. Okay, maybe it's not ready now. The next person I have is Rabiu Ibrahim Abdullahi. You want to ask your question? Oh, okay. I have not. Okay, you cannot unmute yourselves. Okay, you can unmute yourself now. Sorry, the problem was from me. I locked it.
All right. Good evening, sir.
Yes, good evening.
Good evening. The name is Aino Oluwaseun Victor.
All right. Go ahead.
Thank you, sir. I was actually trying, but I realized you not muted us initially. Thank you for today's class. I really appreciate all the effort so far.
You're welcome.
My question is just on the IP addresses you made mention about. You spoke about the classes of IP address. Yeah. Class A, Class B, Class C, D, and down to E.
Yes.
I realize you also mentioned about their ranges 0 to 127 for Class A, 128 to 191 for Class B, and so on.
Yes.
But I want to ask this, still based on the classes of IP address. I realized that the time I was actually reading about them, and I came across a classless IP address. I know you didn't actually mention that, but I just want to ask, when can we actually make use of the classless IP addresses?
All right.
When can we make use of them? What are their benefits? And then do they also have range, just like the Class A, 0 to 127? Do we have something like that for classless IP addresses as well?
Very good question. Now, it is part of what we'll be looking at tomorrow, called classless interdomain routing, okay? And then we'll look at what we call VLSM, variable length subnet mask. These are two concepts that we'll be looking at tomorrow because it will help us when we come to do subnetting. So if you'll be patient, tomorrow when we meet in our class, I'll be able to look at the concept of classless IP addresses that you're talking about, why they are called classless and why these ones are called classful, all right? And then VLSM and then subnetting, all right?
All right, sir. Thank you.
Thank you very much. Rabiu Ibrahim.
Good evening, sir.
Good evening.
Thank you for this wonderful lecture. I have only one question.
Please.
Why is it that this NAT, that is the network address translation, is not applicable to IP version 6? Why is it that the question is this is the question. Why NAT is not applicable to this IP version 6? If yes, In what situation is applicable? If it is applicable, or if it is not applicable at all, then why is it that?
Okay. Thank you very much for your question. Now, the first thing you need to ask first is, why was NAT created? What is the function of NAT? Okay. NAT was created to resolve the issue of depletion in IP version 4. IP version 4 was finishing, and so they needed to create a private IP address and then public IP address. Why are they creating private IP address? So that that set of IP address can be used or can be reused by different people at different locations. All right, since it's going to be used locally. Now, the concept of NAT is just to help translate that local private IP public IP address. In IP version 6, they have made the IP addresses available. In other words, in IP version 6, you don't even need NAT. You don't even need it. Why do you need to translate when you have more than enough? Because the IP version 6 was to resolve the IP version 4 problem. But there are instances where you create something like NAT, and that in version 6. And that concept is when you want to coexist both IP version 4 and IP version 6. For instance, you have IP version 4 in one segment of the network, you have IP version 6 in one segment of the network. Or if your ISP is using IP version 4 and you are using IP version 6, or you are using IP version 6, your IP is using version 4, or something like that. That is where then you may need to NAT. Okay, but in its original sense, if everybody is running IP version 6, you may not need to NAT. So I hope this may have answered your question. All right. The next person we have is Adebowale.
Good evening, sir.
Good evening, sir.
Yes, thank you for the class. Really appreciate your efforts.
You're welcome.
So my question is not about today's class, but rather on the issue of a packet tracer.
Okay.
I joined the class a bit late, so I wanted to log into my account, but I couldn't. So I could only log in through the guest option, and that is not giving me the full facility to make use of for the packet tracer. I've tried to private chat you, but you'll not be responding. Otherwise, I wouldn't have asked for this option.
All right. So when you have that problem, you see when you want to log in on your packet tracer, it gives you two options. It gives you option to log in using NetAcad, or it gives you an option to log in using Skills for All. Okay, so you are free to use any. If you try NetAcad, it doesn't go. Just click Skill for All, and then it should be able to log you in.
But that will ask for my login details, I think.
Yes, it will ask for your login details, the one you are using to write your assessment. So just enter the login details. The same, it would not be a problem.
All right, thank you.
You're welcome. I have Dr. Osho Stephen. Dr. Stephen, okay?
Hello.
Yeah, I appreciate your volume is always low. I don't know how you can help us out.
Okay, are you hearing me now? Good evening.
Good evening, sir.
Thank you for your lecture. It's enjoyable.
All right.
My question is that I think version 4 has numerous advantages. Why would we still like using version 4? Look at me.
Okay, if I understand, you said if version 4 has numerous advantages, why are we using version 6?
No, version 6 has numerous advantage version 4. So when do we see the version 4?
Okay, since version 6 has more advantage than version 4, why are we still using version 4? Is that your question?
Yes, yes.
All right, thank you. So now, it is called a transition because the structure of multiple devices globally has been built based on the IP version 4. All right? A lot of devices have been built based on IP version 4. And so what is happening now is that they're encouraging companies to be building devices that have IP version 6 capability. So that is why you need both of them. So unless in your own organization, all your devices are IP version 6 compliant, then you can do away with IP version 4, right?
Okay.
All right, yes.
Okay, thank you.
All right, so I've seen everybody have signed in their attendance. Let me download it. While I'm downloading it, Malam Umar Nuhu, you can ask your question.
Good evening.
Good evening.
I really want to appreciate actually the way you explain your own things that makes us to understand better. And that's why I just called show that appreciation.
Thank
Hope
you.
you keep it on for us to understand. Thank you very much.
Thank you very, very much, Umar, for these words of encouragement. I really appreciate it. Thank you very much. Okay, ladies and gentlemen, I think we have come to the end of today's class. It's been nice having you.